So today, we're going to be looking at the single-sided swingarm. The single-sided swingarm saves a little bit of weight and frankly just looks really cool compared to a conventional swingarm. But maintenance on these swingarms are a little bit different than a conventional swingarm. And today what we're going to do is take apart the axle in this Honda VFR. Now this is going to look very, very similar to any motorcycle with a single-sided swingarm, and grease the needle bearings, which are an open set of bearings inside the bearing carrier that supports the axle. And it's very, very important that you keep your maintenance up on this. And today, I'm going to show you how. Okay, so the first step in this operation, we're going to take off the rear tire today. And I've already loosened the stud nuts, the wheel nuts on this bike, so we can go ahead and get them off the rest of the way. So the next step, after we've got the rear tire off, we're going to slack the chain so that we can take the chain off of the rear sprocket. And on a single-sided swingarm, you've got the pinch bolt here in the back that holds the eccentric that is the bearing carrier for the axle. So we're going to loosen that one. And then use our spanner to move the eccentric forward and put some slack in our chain. And that should be done by pulling this down. Yep, and you saw how easy that moves forward. Now we have lots of slack in our chain. We can go ahead and take the chain off of the sprocket. Just going to slide that chain out of the way. We don't need to remove the chain guard because the axle is going to slide out towards the right side of the bike. So as long as we can get the sprocket clear, the sprocket carrier clear, we should be good. And I'm pretty confident that we don't need to do that. So now we've got the chain slacked off and off of the sprocket. The next thing we're going to do is take one of the bolts out of this dog bone that you see sitting here. In this case, this is the rear brake carrier. This isn't the case in every single-sided swingarm. Your bike may have something that looks like that, may not. But the reason we need to take this one off is we may need to take the carrier for the rear brake caliper right off. And in order to do that, I'm going to have to disconnect that carrier from the swingarm itself. Now there's two locations where this dog bone is mounted, obviously. This lower one right down here would work as well. This one here has a bolt that runs through to the other side with a nut, and then a cotter pin that runs through the bolt itself. So rather than sacrifice that cotter pin, even though it's not necessarily a big deal, could have just replaced it, I am going to remove this bolt instead, which goes into the casting of the rear swingarm. And the reason that I chose that one, another reason I chose that one, is simply because when I put it back together, I can apply some anti-seize, and we'll make sure that the bolt stays free in the housing and doesn't corrode up and seize. So I've already loosened this off with my breaker bar, and I'm just going to use a ratchet now to take it out the rest of the way. This particular bolt is pretty stiff in here. There's probably some old anti-seize on the threads that are helping hold it in place. So that's down out of the way. The next step is going to be to remove the brake caliper and set that up out of the way. You always want to have a bungee cord handy when you're ready to take your rear caliper off, just so you can support the caliper and the hoses, and that way it's not hanging from the hoses, potentially damaging your fittings or your hoses. So to do that, we'll have to move to the other side. So to remove the rear caliper, we have it being held on to that carrier by 2 bolts. This one you can see pretty well. There's another one way up here that is kind of outside the camera range, and we'll need to take that one off as well. So these are just 14mm bolts. Again, these would have anti-seize in them on the threads when they go back together, and that's what they look like there. So this one is kind of deep in here, and I'm going to use a wrench instead of a socket to get at it. And whenever you're wrenching, try to use the box end as much as possible. If you've got clearance, you're always better off to use the box end instead of the open end to do your wrenching. Helps make sure that the bolt head stays in place and doesn't round off. Your wrench is less likely to slip. You know, like I said, and use that box end until you get the bolt or nut broken loose, and then you can switch around to the open end. Alright, so the rear caliper is off. I just have brake lines running to this caliper. This bike does not have anti-lock brakes. If it did, or if your wheel sensor, speedometer sensor is running off of your rear wheel at the back, sometimes they use the same sensor, the ABS sensor and the speed sensor. You'll have a wire that comes down along these brake lines and going to a sensor that should be mounted stationary somewhere on the carrier there. So just be aware of that you may have a wire if your bike has ABS brakes, or your speed sensor is located back there. So now that we've got the rear caliper off, we can take a look inside and see what the quality condition of the rear brakes are. And we see that these brakes are probably about, I would estimate them at maybe 30% left, which is a whole other project that we'll have to get into to change the rear brake pads on this bike. Obviously they should be done. Okay, so we're ready to remove the axle nut again, and I am using a breaker bar, and because there's a lot of tension with the collar being staked, I'm also using a pipe on the end of my breaker bar to increase the amount of leverage that I have on it and give me more force. So I've put the chain back on the sprocket, and I put the bike in second gear to give me the resistance I need in order to move the axle nut. Then once that's free, I can set the snipe down. So now that we have the nut loose, we're just going to go ahead and use our ratchet in order to get it the rest of the way off. And what you're going to see when you take this nut off is, first off, is that the nut itself is unique and different in that it has this collar on it, and that collar is what you use to stake the nut to the axle, a slot that's in the axle. And that's what that collar looks like, and you can see the part that was staked there and understand how that works. And it goes right into a slot that you can kind of make out there on the top of the axle. So the service manual is going to tell you to replace this nut. This is probably a $30-$40 nut, something like that, maybe $50. I'm going to tell you that as long as the collar isn't chewed up too badly, that you can go ahead and use that nut again. Just try to find a different spot on the collar in which to stake the nut to the axle when you go to put it back on. So you just got to make sure it's, typically you can tighten it a little further and get past that point. Just make sure that you're torqued within spec on the axle. So behind this nut you're going to find a washer, and this washer is just slightly conical on this one. There are other bikes that I've done, it's much more pronounced. In other words, by conical I mean that it has a little bit of a slope to it from the inside out. And when this nut goes back in place, you got to make sure that the center is the furthest pointed out. So you want to have the inside edge of the top of the nut touching against the collar first, and this just gives a little bit of a spring pressure then as the nut tightens up, and then the washer is allowed to compress down, expand out a little bit, and that puts that additional bit of spring tension onto the axle. So the next layer is where the Honda is a little bit unique compared to other bikes, and that is there's an axle spacer down in here that is actually carrying the sprocket carrier onto the axle. And there's a bearing inside, a seal and a bearing inside the sprocket carrier, and this down here is a little bit more difficult to get out. You just got to kind of work it out. I could go around the other side and probably pull the axle and it'll all spill out, but I want to do this kind of gently on this side and make sure that we don't damage anything. So in this case, because there's some tension on it, I just have to work my way around that spacer, the lip on that spacer, with a pry bar. In this case, I'm just using a screwdriver, and get that worked out of the bearing seal, which is holding it in place. It's a good setup because it prevents a lot of water or dirt from getting inside of the axle area. So there it is there. An idea of what that looks like. So this area is free, and we'll be able to move next to slide the whole axle out. Alright, so now that we've got the axle nut off, the spacer out, this assembly of the sprocket carrier, the axle, and the brake rotor should just come apart if we've done everything correctly. So let's see what happens and work these guys apart a little bit. And there we go. So there's the inside of the sprocket carrier, and on this model the outer bearing is sealed, and that is the axle of the single-sided swing arm. There is a seal on the axle right there at the bottom. The axle shaft rides on, you can see it rides on a bearing there, and it rides on a bearing here in the hub. But what we're after here today is, besides a cursory inspection of what's going on inside the axle, make sure that there's no hot spots, that there was no bearing damage, was to check the needle bearings and check the grease on those needle bearings, which are located in the bearing carrier, which is right here. So we're going to take a closer look at that. So the first thing we want to do is make sure that there's no issues with the bearing itself. And all we're going to do is take our finger and put it inside the bearing and roll the bearing around. And we want to check for any rough spots, any snags in rolling this bearing. Anything that would give you any basically pause that something isn't lining up right, or rolling properly. And there doesn't seem to be any of that with this bearing, so I'm happy that that bearing is still serviceable. Now I'm going to do the same thing on the other side here. So the bearing on the left side of the bike is sealed, and what I mean by that is that the race is in contact with the inner race, I should say, is in contact with the bearings, and it's sealed off. In other words, you can't see the actual little bearings, needle bearings, like you did on the other side. So there's actually two on this bike. There's one way on the inside, and then there's another that obviously supports the end of the axle. And again, what you want to do is just stick your finger in there, roll the bearing around, make sure that there's no rough spots, snags, anything that doesn't feel smooth. And this all looks good and feels all right. So the other thing that we're going to do is just inspect the sprocket carrier. There is a bearing inside here as well, and this again is a sealed bearing. There's no reason to change these out unless there's an issue with this bearing to indicate that there's some abnormal wear or stress or anything like that. So based on the condition of the axle, I don't see any of that, and we're good to clean this up, grease it up, and put it back together. Okay, so how we're going to clean this up is we're going to just use a little bit of brake cleaning and wipe it all down and try to free this up. You could probably find a bearing degreaser out there that might do a more effective job, but the reason I like brake clean is because it doesn't damage anything, won't damage the seals that are here, and cleans things up nicely. Again, everything's in good shape here, so we're just gonna clean the dirty grease off as best we can before applying nice new grease to our bearings in there. And the advantage of using brake clean as opposed to a solvent that has detergents in it is that the brake clean evaporates. So we can get this bearing reasonably dry, and the rest of it will evaporate. The rest of the brake clean will evaporate before we even get the grease in there. And we're going to do the same to the axle. We want to get any dirt, any visible dirt off the axle. So in cleaning up the axle, something interesting of note, down here beside the seal, you see that there's a rock or something in there beside the seal. Something we definitely don't want, so you want to make sure that you get that out and discard it, because you don't want anything damaging that seal. So you can see now the axle's cleaned up. This spot, if you're wondering, is the part that sits outside of the swing arm on the nut side, and that's where that collar that we took out, that's what was sitting there. Not concerned about it. Clean that up if you want with a little bit of emery cloth. Just polish it a little bit, but it's not damaging anything to have that little bit of weathering there. What you want to check is where the bearings ride on the axle, and that's this area and this area right here. And you just want to make sure there's no burrs on those surfaces, and that everything is going to run smoothly when you want to put it back together. The other thing you want to do is really concentrate on the splines, and the splines are what drives the bike forward. If the splines are bent, if any of them are missing, like chipped up, that's a bad sign. It's time for a new axle. So we're looking these ones over. There's a little bit of wear on them, as you would expect, but I don't see any issues other than that. So I'm confident that this axle is good to go back in and be reused. So we're putting the grease back into this bearing. We want to make sure that we're using a wheel bearing grease that's rated for the temperatures and the speeds that this bearing is going to turn. So we're just going to take the grease, put it on our finger, and work it into all of the needles while working the bearing around. And if you use a little bit too much, you're just going to have to clean it up. It's going to work its way out as you put the axle in. But better to have a little too much than too little, I always say. But we just want to make sure that's well coated, and then roll the bearing around, and you'll see the grease work its way up and under to the bottom side of that bearing. So run your finger around the inside, make sure that you've got the excess kind of cleared away, put it back on the bearings. You can also leave a little bit of a coat on the outside, this area right here, just to help the seal slide in there, and to make sure that no water or dirt gets in the rest of the way. Now the bearings on the other side are sealed bearings, so we don't have to apply any grease to those bearings. Okay, so before we put this back in, the next thing we're going to do is just apply a little bit of grease to the areas of the axle that carry on the bearings. And of course, because that bearing on the other side is sealed, we can't put any grease around it. Just going to put a small film of grease in the axle just to help it slide in place. The other thing we're going to do is we're going to put some grease on the splines. Now, I did clean up that spot that you saw earlier on this axle, but what grease on the splines does is helps protect that, in this case the sprocket carrier, from seizing onto those splines, because you don't want that. It'll make it very, very hard to take that off, take this axle apart down the road. So again, just put a film of grease on the bearing part of the axle where the bearing rides on that axle. Okay. It's also just going to help protect it from corrosion. So we're lubed up and ready to go install. So before we put this back together, I just wanted to show you how this eccentric works in a single-sided swing arm. So what you see here is that the hole for the axle is off-center to the carrier. And what that means is as you rotate the bearing carrier back, you see that the hole actually moves up inside the swing arm, but you also see that it moves further back. So that would be with the chain fully loosened, slacked, and this would be the maximum amount of tension that we could put in the chain. So all that happens just by rotating this bearing carrier, which is... So just like the splines on the axle, we want to check the sprocket carrier to make sure that there are no damage teeth or splines on the sprocket carrier as well. And these ones all look good, so we're ready to put it back together. So now that everything's lubed up, we're ready to put this back together. And all I'm going to do is insert the axle into the carrier and make sure that the sprocket carrier on the outside is also there, and the whole thing should just slide together without any issues. And that's the way it's supposed to work. So the rest of this is what we're going to do is bolt things up in the reverse order of the way that we've taken them apart. Taking particular care where you have steel bolts in contact with aluminum. In that case, we want to make sure that we apply anti-seize to those areas to prevent them from corroding in place and making them impossible to get out without breaking them the next time. The other thing that we're going to do is pay attention to torque specifications. Most importantly, the axle torque specification, which is going to differ from bike to bike, but if you check your service manual, you'll be able to find that information out. So we're going to put the axle nut back on, and we're going to start with our collar, in this case, on this side. This is a standard collar. It doesn't seem to have any taper to it. On different bikes like the Triumph Single Sided Swingarm, this collar actually tapers in. It's quite big. Very important this goes in first, and now with that little bit of grease just slid in place. If you remember, it was a little difficult to take it out. Now it just slides in like it's perfectly fit. Again, this is a little bit of a conical washer, so we have to make sure. You can sometimes, if you can't see it, you can do it by feel, or you can put it down on a level surface in order to see the shape of it. But we know that the first contact is the outer edge. So what we want to do is make sure that outer edge is contacting the spacer first, and so the inner edge is raised or is further back, and that's what we want, so that there's a little bit of spring tension on that axle when we tighten this up. And then the final thing we need to do is put this axle nut back on. And then we're going to torque it to spec and stake it on. So we're ready to torque this axle nut up. 201 Newton meters, or 148 foot-pounds. And you've maybe heard me say it before, but if you don't have a torque wrench, get one. There's just no way that you can trust your life to feel. And you want to make sure that everything you do is torqued appropriately. So the final thing we're going to do is stake that axle nut. So what we're going to do to stake the nut to the axle, we're going to find that slot in the axle and take a good quality punch and punch the collar down with the punch into that slot. And we wind up with a staked axle nut.